All right, let's dive right in. We're about to tackle the biggest question there is, the ultimate cold case. Where did everything, and I mean everything, come from? Now, this isn't going to be some dry science lesson. Think of it more like the greatest detective story ever told. So, you might want to get comfortable because our investigation starts right now.
This is the question, isn't it? It's something we've been asking for thousands of years. From ancient philosophers just trying to make sense of the world, to today's scientists using these incredible telescopes to peer back to the dawn of time itself. It's the ultimate mystery, and it's what really drives us to figure out our place in this huge cosmos. And just like any great detective story, the answer didn't just fall into our laps. Nope. It was this slow, careful process of finding little clues, following the evidence wherever it led, and this is the important part, being willing to toss out old ideas when new, undeniable facts showed up. So, let's follow those breadcrumbs. Okay, so our investigation kicks off with the very first major clue, and this one was a real bombshell. It completely blew up what everyone thought they knew about the universe. See, for most of history, even for geniuses like Isaac Newton, the universe was just there. It was static, unchanging, like a painting on a wall. But then, in the 1920s, this physicist and priest, Georges Lemaitre, had a radical idea. He looked at Einstein's own math and basically asked, hey, what if we've got it all wrong? What if the universe isn't static? What if it's getting bigger?
Now, that was a pretty wild idea, but the hard evidence to back it up came from an astronomer named Edwin Hubble. He was looking at distant galaxies and noticed that their light was stretched out, or redshifted. The easiest way to think about this is to imagine an ambulance siren. You know how the pitch gets lower as it drives away from you? Redshift is the exact same thing, but for light. And what Hubble found was just incredible. Almost every galaxy out there was redshifted. They were all moving away from us.
This evidence was so powerful, it even made Albert Einstein change his mind. He had actually tweaked his own famous equations, adding in something he called a cosmological constant, pretty much just to force the math to show a static universe. When he saw Hubble's proof, he had to admit he was wrong, and he later called that little tweak his biggest blunder. So one part of the case was officially closed. The universe was expanding.
Okay, so think about it. If the universe is expanding, that means if you rewind the tape, it must have been smaller in the past, right? Keep rewinding, and everything must have started from a single, unbelievably hot, dense point. That was the theory, at least. But every good detective needs a smoking gun, and for this theory, the proof was found completely by accident. So fast forward to 1965. You've got these two young engineers at Bell Labs, Arno Penzias and Robert Wilson. They were working with this huge radio antenna, but they weren't searching for the secrets of the cosmos. They were just trying to get a clear signal for satellite communication. But they couldn't. Something was getting in the way. They kept picking up this faint, annoying hiss, and it was everywhere. No matter where they pointed the antenna, day or night, the hiss was there. They checked everything. They even climbed inside the antenna and cleaned out what they politely called a white dielectric material. You know what that was? Pigeon droppings. But even with the pigeons gone, the hiss was still there. And then it hit them. They hadn't found interference. They had accidentally stumbled upon the afterglow of creation itself, the faint leftover heat from the Big Bang that scientists had predicted had to be out there. Now, as the universe has expanded over billions of years, this radiation, which we now call the cosmic microwave background, has cooled way, way down. Today, its temperature is a chilly 2.7 degrees above absolute zero. This is the oldest light in the universe. It's literally a baby picture of the cosmos when it was just a toddler, only about 380,000 years old. So, with all this evidence in hand, we can now do something truly incredible. We can basically reconstruct the crime scene. We can rewind the tape all the way back to the very first moment of time. But first, let's clear up a really common misunderstanding. The Big Bang wasn't an explosion in space like a firework. No, it was the expansion of space itself. The best way to picture it is to think of a balloon with a bunch of dots drawn on it. As you blow up the balloon, all the dots move away from each other, but there's no center to the explosion, right? The expansion is happening everywhere, all at once. That's the Big Bang. And those first moments were just unbelievably chaotic. I mean, in the first teeny tiny fraction of a second, the universe inflated from something smaller than an atom to something absolutely massive. By the time it was just 1 second old, All the building blocks, like protons and neutrons, had already formed. It's just mind-bogglingly fast. And then, within the first 3 minutes, in a process called nucleosynthesis, the universe basically cooked up the first elements. And the recipe was really simple: about 75% hydrogen, 25% helium, and just a tiny pinch of lithium. And here's the kicker. That primordial recipe is a perfect match for what astronomers see today when they look at the oldest stuff in the universe. It's another perfect clue. Now, this is where this giant cosmic story becomes incredibly personal. The simple hydrogen atoms in the water that makes up most of your body, they weren't made in a star somewhere. No, they were forged in those first 3 insane minutes after the Big Bang. You are literally carrying around pieces of the beginning of the universe inside you right now. But just when our cosmic detectives thought they were ready to close the case, they took a closer look at the crime scene and realized it was way bigger and a whole lot weirder than they ever imagined. They realized that everything we've been talking about, all the stars, the galaxies, you, me, all of it makes up just a tiny, tiny fraction of what's actually out there. So the next big mystery starts in the 1970s with an astronomer named Vera Rubin. She was studying how galaxies spin, and she saw something that it didn't make any sense. The stars way out on the edges of galaxies were moving so fast that they should have been thrown off into space, like a kid flying off a merry-go-round that's spinning way too fast. The problem was right there in the data. See, based on all the stuff we could see, the stars, the gas, all of it, the speed should have dropped off the further away you got from the center. But it didn't. The speed stayed high. And that could only mean one thing. There had to be a ton of extra, invisible matter providing the extra gravity to hold it all together. The only thing that could explain it was some kind of invisible, mysterious substance acting as a sort of gravitational glue. They gave it a name: dark matter. Not because it's spooky, but simply because it doesn't give off any light, doesn't reflect light, it's completely invisible to us. And this leads to a pretty shocking reality check. When we add everything up, the atoms that make up you, me, the Earth, and every star you've ever seen, that's less than 5% of the universe. About 23% is that mysterious dark matter. And the rest of it, the huge majority, well, that's something even weirder, called dark energy. A mysterious force that's not just allowing the universe to expand, but is actually making that expansion speed up. The discovery of this dark energy, the biggest single ingredient in our universe, naturally leads us to the final chapter of our cosmic story, the end. So, how's it all going to end? Well, right now, there are 3 main theories. There's the big freeze, where the universe just keeps expanding forever until everything is cold, dark, and empty. A bit more violent is the big rip, where that accelerating expansion gets so powerful it literally tears apart galaxies, then stars, and eventually even atoms themselves. Or, if gravity somehow makes a comeback, we could have a big crunch, where everything collapses back down into a single point, maybe even setting the stage for a whole new Big Bang. It's such a massive, mind-bending story of beginnings and possible endings, but it's also our story. As the great astronomer Carl Sagan so beautifully put it, we are the universe becoming aware of itself. The stuff we're made of was forged in the hearts of dying stars. We are, literally, star stuff, connected to this incredible cosmic history. And so our investigation doesn't really end with a neat and tidy answer. It ends with an even bigger, more profound question. Some of the latest theories suggest our Big Bang might have been just one of many, happening in a vast cosmic foam of bubble universes. Which leaves you to wonder, what other incredible mysteries are still out there, just waiting for the next generation of cosmic detectives to find them?